Alright guys, hello and welcome to today's lesson. I'm Mr. Ludden and today we're going to be looking at patterns and the nth term and how they're asked in an exam style format. So I'm going to jump straight in. There are three types of patterns that you need to be aware of for your junior cert, and they are linear, quadratic and exponential patterns. I'm just going to have a quick walk through each one of these, especially the first two, especially linear and quadratic ones. Exponential patterns, in your exam you tend just to have to be able to identify them, but we will have a brief look at those as well. But in this video our main ones are our first two, our linear and quadratic ones, for the reason that they're the most popular in a patterns type question, and also what you learn today links in heavily with functions as well. So for linear patterns, your first difference is constant, so the difference between your terms, and I'll just get my highlighter just so you can see what I'm talking. So your first difference is constant. So if you had a sequence like 2, 4, 6, 8, 10, you'll notice that it's going up in twos. Those twos do not change, they are constant. When you get your nth term, and that's something we're going to be looking at today because it's something that a couple of people have some trouble with, your answer is going to look like an+c just over here. And what your job is to find out is what the a is and what the c is. If you're asked for your nth term, there's going to be the letter n in your answer. So if you're finding your nth term, we're going to leave this n here, but we have to find out what our a and our c is. So it'll look something like maybe 3n plus 5, or 7n minus 10, or minus 8n minus 13. Your a and your c can be positive or negative whole numbers. For your quadratic patterns, just a jump up from your linear patterns, your second difference is going to be constant, and it's going to be a small bit more, a few more bits to find in regards your constants in your general form of your equation. So what you need to find out is what your a is, what your b is, what your c is, and I'm going to show you how to do that today. And then for your exponential patterns, as I said, you just have to be able to identify those really in an exam type setting. And the difference here is that for your nth term, it's your power that changes. Your a here at the bottom, the base of your number here, will stay the same, but your n up top will change. So in the junior cert they usually talk about 2 to the power of n or 3 to the power of n, but just be careful, they could talk about 4 to the power n or any number really to the power of n. You'll notice that the difference between your exponential ones and your linear and quadratic, in your quadratic, the 2 here does not change. So if there's something squared, your n squared, you know it's a quadratic. If there's an n on its own, you know it's linear. What I should say there is an n on its own with no higher power of n along with it in the equation. So that's how you identify what pattern is linear, quadratic or exponential. But we're going to have a look at a couple of questions just to make sure we're okay with that, and that's what this video is going to be about. I'm going to start with linear patterns, and we're going to talk about the two things that we talked about here, and then we'll move on to quadratic patterns, and there's an exam question that sort of takes everything into account that we're going to have a look at as well. So for now, linear patterns, we're going to have a look at these two questions here. So this is to prove that something is linear. To prove that something is linear, we need to prove that, our first difference is constant. So for our first example here, the way I'm going to do that is I'm going to just get my red pen. The difference between 2 and 7, in other words, what would I add to 2 to get 7? I'd add 5, and that's plus 5. What would I add to 7 to get 12? That'd be plus 5. What would I add to 12 to get 17? That would be plus 5. what would I add 17 to get 22? Plus 5. You'll notice that my 5's here, they haven't changed all the way up. They're constant. So that right there is my first difference. First difference. And seeing as they're all the same, this right here, and I'll just get my highlighter, this right here is linear because my first difference is the same. My first difference, just to finish that, is constant. Let's try the second one here. For the second one, to get from 12 to 9, I take away 3. To get from 9 to 6, I take away 3. From 6 to 3, take away 3. From 3 to 0, take away 3. From 0 to minus 3, take away 3. Again, the exact same thing. I know it's a minus number, but your linear patterns, they can go up or they can go down. Same thing as our first example. My first difference is constant. First difference is constant. If they ask you in an exam to prove that a pattern is linear, that's all you have to do. Show me what the first difference is and tell me in a sentence that the first difference is constant, and you're getting your full marks. Most students don't have a problem with that. They can identify linear patterns, no problem. It's when you're asked to find the nth term that things sort of start getting a small bit hairy. So what I'm going to do is I'm going to show you two methods of finding the nth term for linear patterns. And ultimately you can decide what you want to use in an exam. There's a sort of logic way of going about doing it, the one that I prefer. I think it makes a lot of sense. And we're also going to have a look at what's in your log tables to help you out. So there's a formula to help you out as well. First things first, we're going to have a look at our linear patterns. And the first thing we're going to have a look at is in this table here, I'm going to fill it out with some numbers. So my first term is going to be 3, my second term is going to be 6, my third term is going to be 9, my fourth term is going to be 12, and my fifth term is going to be 15. And I've just done dots there, that'll go on and on. Now you might recognize those as your 3 times tables. You should recognize those as your 3 times tables. There'd be something wrong if you didn't. But what we're going to have a look at is the position of these numbers in relation to where they are in your sequence. So just a couple of things to point out with my highlighter here. Your first term is 3, your second term is 6, your third term is 9, your fourth term is 12. The numbers up top here, the 1, 2, 3, 4, they represent the position of the numbers, and your 3, 6, 9, 12, well, they are the actual numbers. So if your question just asked you, well, what was the first term, you would say 3. If it asked you what the third term was, you would say 9, and that would be great if that was all that the question was asking you. However, they might ask you what the nth term is, so I've just highlighted that in yellow there. And in order to do that, we need to see what's happening with the rest of our numbers just down below. So what I'm going to ask you is, if we had our 1 here, I'm going to ask you, what would you multiply that by to get 3? And you should be able to see that 1 times 3 times 3 will give you 3. And that's great. We move on to our second term, 2 here. What would we multiply 2 by to get 6? And of course my answer is 3. For the number 3, what would I multiply that by to get 9? By 3. And by now you should be seeing that my pattern there is going to continue all the way. So by 3, by 3. So to get from my fourth term, to find out what my fourth term actually is, like I'm multiplying it by 3 to get my 12. To find out what my fifth term is, I'm multiplying it by 3 to get my 15. Now what you might be asked in your exam is to find out what the nth term actually is. And people are absolutely fine doing this when it's just numbers, when you're asked about your first, second, third or fourth term. But when you're asked about the nth term, people tend to lose their minds a bit. The nth term is just a fancy way of saying, well, you don't know what term you want. Can you find out a rule for me? And your pattern, the one that we found out for my first, second, third, and fourth and fifth terms here, it's going to continue on all the way up here. You multiplied 1 by 3 to get your first term. You multiplied 2 by 3 to get your sixth term. If I follow that pattern on, if I multiply n by 3, I will get my nth term. So just rub. If I multiply n by 3, the best way of writing that is 3n. Now just looking a small bit closer at that, 3, 6, 9, 12, 15 will give you the name of that pattern is 3n. This here is also known as your 3 times tables. So if your 3 times tables, if the name of that is 3n, well, your 4 times tables, 4, 8, 12, 16, the name of that would be 4n. If you were asked for your 10 times tables, the name of that would be 10n. If you're asked for your 20 million times tables, you would have 20 million right over here. So that would be great if you were given your times tables like starting at 3, 3, 6, 9, 12, 15. That would be fantastic. However, what you might be asked is something like this. Just get my black pen. Okay, what you might be asked is something like this. 5, 11, 17, 23, 29. Okay, and you might ask yourself, well, if we tried to find out what was going on in this scenario here, what our nth term was, we'd have a small bit of trouble because, yes, this is going up in sixes. So plus 6, plus 6, plus 6, plus 6. So if you think about that, the only other one of our times tables that goes up in sixes is actually our 6 times tables. So you might think, oh, this thing here, 5, 11, 17, 23, 29, it's going up in sixes, it's my 6 times tables. So it's going to be 6n, like from what we said before. However, you'll notice that this sequence here, and I'll just highlight it, this sequence here does not start with 6, like my 6 times tables. It starts with 5. If this was my 6 times tables, and I'll just write this down here, my actual 6 times, let me just get rid of that. I'll do this in green. My actual 6 times tables would be 6, 12, 18, 24, 30. So that right there, seeing as it starts with 6, will be my 6 times tables, in other words 6n. But if you look at my original question, this one here, they're not the same. They're one off every single time. So what I'm going to ask you is, well, and I'm just going to get rid of this bit here. There we go. Let's get rid of that. This right here is my 6 times tables. I want to know how to get to my original question. So how to get to the 5, 11, 17, 23, 29. So if you think about it, to get from 6 to 5, I would take away 1. To get from 12 to 11, I would take away 1. To get from 18 to 17, take away 1. And that pattern is going to continue on all the way. If I continue it all the way up to my nth number, so 6n, if I take 1 away here, if I have 6n, take away 1, well, what I'm going to end up with is 6n, take away 1 up here. And that right there is the name of that pattern right there. I might just try one more, and I will go through this a small bit quicker, just to see if we can get the hang of it. So I'm just going to rub this out now, and I'm going to go with another. There we go. Okay. So I'm going to go with another linear, let's go black. I'm going to go with another linear sequence, and this time I'm going to go with, let's go 8, 13, 18, 23, 28. Now you might ask yourself, oh well, what's this going up in? It's going up in fives. So the times tables that go up in 5 are obviously my 5 times tables. That'd be 5, 10, 15, 20, 25, and the name of that is 5n. So my original question here is going up in 5s as well, but what you have to ask yourself is, how would I get from my original 5 times tables up to what's asked in my question? So how would you get from 5 to 8? Well, you're going to add 3. How would you get from 10 to 13? You're going to add 3. How would you get from 15 to 18? You're going to add 3, and that's going to be the same way all the way across, plus 3. So if I go all the way to my 5n, well, if I had 5n, and if I'm following the pattern here, and if I add 3, what I'm going to end up with is 5n plus 3, which is the nth term of this thing here. So what we're actually looking at, just to highlight it again, this thing here is my 5 times tables, but I'm adding 3 to each one of them. So the first one of my 5 times tables would be 5, but I'm adding 3, so I'm going to get 8. The second one of my 5 times tables would be 10, but I'm adding 3 to get 13, and so on. Guys, that's the first method of getting your nth term for linear patterns. The second term is using your formula in your log tables. And in your log tables, on page 22, you have something like this. Now I just want to highlight what you're actually using, and just the words here, just so you don't get mixed up if you are using your log tables. The word arithmetic here means the same thing as linear. So arithmetic is linear. So if you are using your log tables, what you're going to be using is this formula right here. On the same page, you are given ones for geometric sequences or series. We're not going to have a look at those until your leave insert. So you don't need this, you don't need this, and you don't need that. Also, you'll notice on the left hand side here, Tn is what's given to you here to find your nth term. You also have another formula below it, Sn. Sn is the sum of all your terms when you add them together. That doesn't tend to be asked at junior cert either. So for today, I'm going to put a line through that, and we're just going to concentrate on what's in red here. So for an arithmetic sequence, now in arithmetic, remember it means linear, we're going to use Tn is equal to a plus n minus 1 d. So I'm just going to write that out just below. Tn is equal to a plus n minus 1 brackets d. Now, the biggest thing here is, if you are using this formula, you need to know 2 things. I'm going to get my highlighter. You need to know what a is, and you need to know what d is. Your a is your first term. So I'll just write this down here. Actually, do you know what? I'm not going to have enough room there. Your a is your first term, and your d is your common difference. So in this equation, or in this sequence here even, your a is 5, and your d is 6. Your d is 6, if you can see, is because you are adding 6 each time. Add 6, add 6 to get from one term to the other. Those 2 pieces of information there are the most important things that you need to get out of your linear pattern. Once you do that, you're just filling it into your formula and you're simplifying it. So over here, I'm going to do that. We're going to say that Tn is equal to, now we know that a is 5, plus n minus 1, and D is 6. So just get my black pen. Once you have your A and your D substituted in, the last thing you need to do is tidy that up. So you would have seen this part here written usually as 6 in minus 1. In your formula, the D is on the outside there, but it makes no odds. It's the same thing as what's up here. So just to be aware of that. So I'll just do this as it is. 6 times n is going to give me 6n. 6 times minus 1 is going to give me minus 6, and you still have your 5 on the outside there. 5 plus that. So your nth term, your Tn, is 5 plus 6n minus 6. Now you can tidy that up. You've got your 5, and you got your minus 6. So that's going to be 6n minus 1. Tn is equal to... Now, a couple of minutes ago, we did the same question, if you can remember. We did the same question with our method using our times tables. You're going to get the exact same answer. So with your linear patterns, it's up to you how you go about getting them. Whether you want to use your times tables, like what we've done here, or whether you want to use your page 22 in your log tables. Alright, I'm going to take a quick break there. I'm going to pause the video and I'll be right back with quadratic. Alright, I'm back. We just finished off on linear patterns there. So the next thing we're going to have a look at, just to go back to our key points, that's our linear patterns, and the two things there we covered. Our first difference is constant, and our answer is going to look like something n plus something at the end. So if we look at the last thing we did, Tn, for this answer here, Tn is equal to 6n minus 1. Well, it does look like our general form of Tn is equal to an plus c, and in this situation my c would be minus 1 and my a would be 6. So they might ask you at the end of the question, they might say leave your answer in terms in the form Tn is equal to an plus c. If you had this as your answer, you were absolutely perfect. You had all your marks. So we're going to move on to quadratic patterns now, and we just need to be careful that we know the difference between quadratic patterns and linear patterns, and we need to be able to identify them. So for our quadratic patterns, the first thing we need to do is identify, well, is it quadratic or not? And we're going to start off this the same way as our linear patterns, and we're going to find our first difference. So for this here, I'm just going to draw out my arrows. For my first difference between 2 and 6, my answer is 4. For 6 and 11, my answer is 5. For 11 and 17, that's 6. To get from 17 to 24, that'd be 7. And to get from 24 to 32, that would be 8. So you'll notice that my first difference is not constant. So this is not linear. And another word for linear, if you remember from a couple of minutes ago, is arithmetic. It's not arithmetic or linear, and those two are the exact same things. So if our first difference is not constant, we're going to go to our second difference. So we're going to take our 4, 5, 6, 7, 8, and we're going to find a difference between all of those. And you'll notice that to get from 4 to 5, you get 1, 5 to 6, 1, 6 to 7, 1, 7 to 8, 1. So here's the line that will get you your marks. Like this bit I've done in red here is you're working out, but you need to tell me that this is quadratic because the second difference is constant in order to get your marks. Right now you'd be looking at maybe 2, if not 3 out of 5 marks, but to get your full 5 marks, you need to tell me that your second difference is constant. Sequence is quadratic. The amount of people that I've seen who would do this question, do their working out, and then not tell me that the second difference is constant or the sequence is quadratic is unreal. And more often than not, the question says like, show this is quadratic, or no, if it was to show this was quadratic, that would nearly be enough. but if it asks you what type of sequence this is, the amount of people who will do this work for me, they'll do that, but then they won't tell me what it is. And yeah, it breaks my heart, to be honest. Okay, so just to round that off, quadratic patterns, if your second difference is constant, the sequence is quadratic. Okay, now the most difficult thing about quadratic patterns is to find out what the general term is, and it looks something like this. So right now, I'm just going to take a quick step back to my key points. Your key points, for linear ones, we've done that. We just have to do my second difference is constant for my quadratics, and right now we're going to concentrate on this, finding out what A, B, and C are. And okay, so back here, if you were given a quadratic sequence like that one above, but you're asked to find the nth term, so Tn, you need to be able to find out what A, what B, and what C are. And the first thing we're going to have a look at is your A. Your A is going to be half of the second difference of your quadratic pattern. So if we go back to the quadratic pattern that we've done, our second difference was 1. So if we were to try and find out what our A is, if we were putting this sequence into our general formula here, my A would be a half of 1. So this A would be a half of 1. Now half of 1 is a half, so my A would be a half. In regards to your B and your C are sort of tied together. I'm just going to put those in orange here. And what we're going to do is, with these, we need to use what we found out about our A and what we know about our first term and our second term in order to get two equations where we don't know B and don't know C. And at the end, we're going to need to use simultaneous equations to find out what B and C are. So there's quite a few steps to this sort of question. And an example of this came up in 2018, question 8C. So what I'm going to do now is I'm going to go through that question with you, and we're going to take a special interest in the 2018 question 8C part. All right. Oh, sorry. What did I say? I said 2018. That shouldn't be 2018. That should be 2015, as I've said up here. Okay, so 2015 question 8A. The first part of your question looked like this, and it asks you to find out the next two terms in your next two stages in the pattern. Now, this is something that you might have done in 6th class, but it's amazing the amount of people who can mess this up. So just be careful with this, I suppose. It's my best advice to you. Now, I was going to draw my writing out here, but I said I would steal the answer straight from the marking scheme, save myself a bit of hassle. So guys, just a few things to be aware of. Obviously, like, it's going up in a sort of nearly a diamondy shape, for want of a better word. The amount of people I've seen who they've seen the first 3 stages, and then for the 4th and 5th stage they just give me this and this, which would get you, if you got 2 out of 5 marks, you'd be doing well for just those 2 things. Just be careful, because in this like, you're going up in steps here, you're going up in steps here, and I know it doesn't look good, but you're going up in steps in stage 1 as well. Make sure you go up in your steps here as well, and also here. And you'll notice that if you do break it up into just like the most going across and the most going down, well, you've got 1, you've got 3, you've got 5 going across, you've got 7 going across, you've got 9 going across, and the same is going to happen going up and down. So I suppose I could talk about this way too. I could talk about this all day, I suppose, but just in summary, just be careful with those, because the amount of people who drop marks in that part, it's criminal, really. Last thing, use a ruler. Use your squares in your exam paper. If it's all over the place, the marking scheme mightn't allow all your marks. So if you had something like your boxes not on top of each other, something like this, I can't give you marks for that. So just be careful, be neat, is what I'm telling you. Okay, enough about part A. Let's go to part B. Part B tells you that the perimeter of stage 1 of the pattern is 4 units, perimeter of stage 2 of the pattern is 12 units. So I'm just going to write out those two. 4, 12. Find the general formula for the perimeter of stage n of the pattern, where n is a natural number. Okay, so I don't have enough information with just the perimeter of my two stages first. So I'm going to go back to my question, and the perimeter here is 1, 2, 3, 4. So I'm not going to write a perimeter every single time. The perimeter for that one is 4. The perimeter for this one, as it told me, I'm just going to check 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12. That's okay. For this one, so 4, 12. For this one, it's going to be 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 20. For this one, go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28. And as you can see, this looks like it's going up in eighths. So if I was to count all of these ones here, 28 plus 8 should give me my 36. And I'm just going to, actually, do you know what? I'll leave that as an exercise for you guys too. If you want to count that, you will get 36. So that's an exercise for yourself. So 4, 12, 20, 28, 36, 20, 28, 36. First thing, we need to find a general formula. Now, right now, we don't know whether this is linear or quadratic, so we better find out. To find out, we're going to find our first difference and just hope that it's constant. If it's not constant, then we're going to have to look at our second difference, and then it's going to be quadratic. So from 4 to 12 is going to give me 8. From 12 to 20 is going to give me 8. From 20 to 28 is going to give me 8. From 28 to 36 is going to give me 8. So I know that this is linear. Unfortunately, in the question, that's not what it's asking me. It's asking me to find the general formula. So this is up to you now. You can use the method using the times tables, or you can use the formula in your log tables on page 22. I'm going to go with the first option, the first method. So my 8 times tables, I know that this goes up in 8s, but it's not my 8 times tables. My 8 times tables goes up in 8, 16, 24, 32, 40, and that would be my 8n. That would be my 8n. Now, if I want to get from what I've just written out back to the original question, I realize that, and I'm just going to get rid of this here, just so you can see what I'm doing. 8 minus 4 will give me 4, 16 minus 4 will give me that, 24 minus 4 minus 4 minus 4, so my 8n minus, if I take 4 away, actually I shouldn't put that there, minus 4 is going to give me 8n minus 4 as my general term. So let's just make sure that we've got that, where n is an element of n, where n is a natural number. Well, n here has to be a natural number, because remember, your n here is like the position. So your first term, your second term, your third term, your fourth term. We're not looking at like your 4th and a half term. So for this, like your terms and conditions here, your n is equal to, your n is an element of your natural numbers. We're all good there. So I'm just going to give that a tick. You could also have done that with your formula. if you want to do your formula, you should get the same answer as me. If you haven't, then you need to practice your formula. Now, I'm just going to take another break for myself because in a minute we have another question. 2015 question 8 part C says find a general formula for the area of stage n of the pattern. So the area now, not the perimeter. The perimeter is what we did in part B. That was the perimeter. This here is the area. So just going back to the question, we're counting up the actual squares in all our patterns. So I did that already and I got 1, 5, 13, 25, 41. I'm going to take a couple of minutes for myself. I'm going to pause the video and I'm going to be back to you in a minute or two to show you how to get the general formula for this right here, because this right here is going to be quadratic. So we're just going to be careful with that. Alright, back again. I'm going to jump straight into this question. We're going to find out what type of sequence this is. So I'm going to say 1 and 4, give me that. 8, 12 will get me to there, and 16. So we realize our first difference is not constant, so this is not linear. So not linear. So we're going to go to our second difference. We're going to find 4 and 4, 8 and 4, 4. So quadratic. Seen as my second difference is constant, this right here is going to be quadratic. Okay, now the fun begins. What you need to find out is, you know it's quadratic, so you know it's going to look like this. Tn is equal to a n squared plus bn plus c. You know it's going to look like that. And what you need to find out is what your a, what your b, and what your c is. So if you look back at, or if you were to rewind to the start of the video, also in the description I'll have your step-by-step guide on how to do this. So if you want to look in the description for this, your a here is going to be half your second difference, e_m_c_a. okay, so half your second difference, that's a half by, now my second difference, remember we got that, it's 4, so a half of 4, so half of 4 will give you 2. So you know that right now your Tn is going to be 2n squared plus bn plus c. We found out what the a was. So that was the, I suppose that was the easy part of that question. So just to give myself some room, I'm just going to move down to a new page, and I'm going to bring that with me. So I'm going to have Tn is equal to 2n squared plus bn plus c. And in order to find out what my b and my c are now, we need to have a look at a certain piece of information from our original sequence. So my first term is 1, my second term is 5. I'm going to use that here. So my first term, my T1 was 1, and my second term, my T2 was 5. We are going to use these two pieces of information to get two equations from my main formula. So right now, all that we're dealing with are these three things here. So what I'm going to do is I'm going to substitute this fact here, my T1 is equal to 1. I'm going to substitute that into my formula here. So I'm going to have that T1. Now I've substituted 1, if you look at these two, if you compare these two together, I've taken out my n, I've put in 1. So on this side here, I'm going to have to do the exact same thing. Wherever I see n, I'm going to have to take that out, and I'm going to have to put in 1. So I'm going to have 2 times 1 squared plus b times 1 plus c. Now, if you were to think about it, T1, that's your first term. If we look back to our sequence, my first term is 1. So I'm going to say that 1 is equal to 2 times 1 squared, which is going to give me 2, plus b times 1, which will give me b, plus my c at the end. Now, in order to just make sure I have my variables on one side and my constants on the other, I'm going to take 2 away from both sides. And what I'm going to end up with is minus 1 is equal to b plus c. So I have my first equation there. Now I'm going to do the exact same thing over here with T2 is equal to 5. And I'll just make sure. Okay, so I'm going to have the T2 is equal to, now remember, I had Tn up here on top. Now I want to find out what T2 is, so I've taken out the n here and I've put N2. So on the other side of my equation, I'm going to have to do the exact same thing. So I'm going to have 2 times 2 squared plus b times 2 plus c. Now, if you look at this, my second term was 5, and if we look back at our original sequence, my second term was 5 as well. So it's literally exactly what I've written. I've just written it in a different way here. If my second term is 5, then 5 is going to be equal to 2 times 2 squared is going to give me 8, plus 2 times b plus c. Now if I was to tidy that up, I'm going to take 8 away from both sides. And what I'm going to end up with is minus 3 is equal to 2b plus c. And that right there is your second equation. So over here, I've got equation number 1. Actually, let me write that in. Equation number 1 and equation number 2. And right now you've got to solve those by simultaneous equations. I'll do that very quickly for you. I might do simultaneous equations in another video if there's people having trouble with that, but for now I'm just going to fly through this. So b plus c is equal to minus 1. That was my first equation. My second equation was minus 3 is equal to 2b plus c. So I'm gonna take away everything from both sides. Take, add, and what I'm going to end up with is minus b is equal to 2. So that means b is equal to minus 2. And if b is equal to minus 2, well, I'm going to substitute that into equation 1. My equation 1 says that b plus c is equal to minus 1, but I know that b is minus 2, so minus 2 plus c to minus 1. If I add 2 to both sides plus 2, I'm going to get that c is equal to minus 1. Alright, so just where I have room, just put that line in again, just where I have room under here, we found out what b is, we found out what c is. So finally to answer our question, Tn was an squared plus bn plus c. So that means Tn is equal to a. We found out a was 2 from this part here, if you remember. My a was 2. So it's going to be 2n squared plus, what was my b? Oh, my b is minus 2. So minus 2n, and my c is minus 1. That right there is your answer. So if they were giving you that question, I'd imagine that question there, the C part, I didn't check the marking scheme, but I imagine it'd be at least 10 marks. You might even be lucky and get it as a 15-mark question, because it takes in quite a lot there. Yeah, I think the best thing you can do at the moment is to look through the last sort of 5 minutes again, especially the 2015 question 8 part C, and just let that digest with you. And what I'll probably do in class is give you, well, not in class now, because the coronavirus. Don't know when we'll be back, but I'll probably email you a couple of questions that look very, very similar to this. So just to finish off that question, 2015 question 8 part D asks you what kind of sequence, linear, quadratic, exponential, or none of the above do the areas follow. Now you've done all the hard work with your areas, so the 1, 5, 13, 25, 41. You had already found out it is quadratic. So 1, 5, 13, 1, 5, 13, what was it? 25, 41. If you did out your first and second difference again, you could say quadratic because second difference is constant. Also, like that's full marks, but if you want to say like your Tn that you found down here, 2n squared minus 2n minus 1, 2n squared minus 2n minus 1, that was your Tn. Highest power of n is 2. What I'm talking about there is that it has an n squared. It doesn't have an n cubed or an n to the power 4. So this bit right here, the last thing I've written, is enough of a reason to say that this thing here is quadratic. Okay. Guys, there was an awful lot in that question. I know I've only done one exam question today, but there's an awful lot in that. Just to go back over the key points. 3 types of patterns you need to know. Linear, quadratic, exponential, and what they look like. We've had a look at linear and quadratic today. Exponential, I might have a look at that in another video. These are heavily linked to functions questions, so the next video I'm going to do is something along the lines of functions, which will link heavily into what we've done here. So what I've done in this video, not just patterns, not just the nth term, but an awful lot of stuff that will help you with your functions, graphing functions again. Alright, stay tuned for the next video, and if you have any questions, any problems, just let me know by email, or if you want to comment on the video, whatever, just let me know. Alright, that's a wrap.